In JavaScript, some of the simplest looking object properties are actually hiding a pretty big secret. Yeah, they look like they just hold data, but under the surface, they can trigger all kinds of powerful logic. So today, let's pull back the curtain and see how they really work. Have you ever wished that reading a property didn't just return a value, but, I don't know, calculated it right there on the fly? Or what if assigning a value to a property could kick off a whole validation check? Well, this isn't some what if fantasy. It's exactly what JavaScript lets us do. So when you get right down to it, JavaScript really has two main types of properties. We all know data properties, right? That's the classic key value pair we use every day. But the real power, the upgrade, lies in accessor properties. You can think of them like these little secret agents hiding inside your objects, ready to spring into action. So how do we make these special properties work? Well, that's where getters and setters come into play. These are special functions that run automatically whenever you read from or write to a property, transforming it from just a boring box for data into a dynamic, powerful tool. Okay, let's get our hands dirty with an example. We'll start with this super simple user object. As you can see, it's just got two basic data properties, name and surname. It's a totally standard setup, but we're about to make it a whole lot smarter. So what if we need a full name? Sure, we could add another property and try to keep it synced up manually, but that's a recipe for bugs. There's a much better way. Enter the getter. By using that get keyword, we're creating a property that literally calculates its value on the fly just by combining name and surname every single time it's accessed. It is always automatically up to date. In this, right here, is the magic trick. To get the full name, we just write user.fullname. Notice that? No parentheses, no function call, nothing. It looks and feels exactly like a plain old property, but our getter function is doing all the work behind the scenes. That's what makes this so clean and elegant. Okay, so reading the property works like a charm. But what happens if we try to assign a new value to full name? Bam! We hit an error. And why is that? Well, it's because we've only told JavaScript how to get the value. We haven't given it any instructions for how to set it. For that, we need a partner in crime. And that partner is, you guessed it, the setter. By adding a function with the set keyword, we can define exactly what should happen when we assign a value to full name. Our setter here is pretty smart. It takes the incoming value, splits it at the space, and then correctly updates the underlying name and surname properties for us. So what have we actually created here? The key thing to realize is that full name has become a virtual property. It doesn't actually store any data itself. Nope. Instead, it acts like this smart interface that manages other real properties. It's not data, it's pure logic disguised as data. Okay, so that's the high-level view of how they work. But to really master them, we gotta pop the hood and take a look at how the JavaScript engine actually defines and sees these properties. See, behind the scenes, every single property has this internal thing called a descriptor that spells out its behavior. For a normal data property, that descriptor has keys like value and writable. But for an accessor property, the structure is totally different. It has no value or writable keys at all. Instead, its identity is defined by its get and set functions. This difference is absolutely fundamental. And this brings us to the single most important rule you have to burn into your brain. A property can have a value or it can have a get set pair. It absolutely cannot have both. You have to pick a lane and stay in it. And trust me, JavaScript is not going to let this slide. If you try to mix and match them, say you try to define both a get function and a value on the same property, you are going to get this very specific type error. The engine just throws up its hands and says, nope, invalid property descriptor. Alright, now that we know the rules of the road, let's check out a really powerful real-world use case for this. We can use setters to act as a guardian for our data, basically validating it before it ever gets stored. Okay, here's the game plan. Let's say our goal is to prevent users from having super short names. The strategy is to create a private property underscore name to hold the actual data. Our public name property then becomes an accessor, and its setter acts as our gatekeeper. When a new name comes in, the setter checks its length. If it's good to go, the value is stored in underscore name. If not, it's rejected. The public getter then just serves up the value from underscore name. Simple, right? We get total control. Now you might be wondering about that underscore in underscore name. This isn't some magic syntax that JavaScript enforces. It's a really strong, widely understood convention in the developer community. When you see a property that starts with an underscore, it's a signal from one developer to another saying, hey, this is an internal thing. Please don't touch it directly. Use the public getter and setter instead. Alright, let's move on to our next big use case, which is, honestly, it's brilliant for keeping code alive over time. Getters can literally act like a time machine, giving you backward compatibility even after you make major changes. So imagine this. For months, maybe years, your application has been running on a user object that has a simple age property. All your functions, all your components, they all rely on being able to read user.age. But then you have a realization. Storing birthday is way better. It's more precise, it doesn't go out of date, and you can always figure out the age from it. So you make the smart move and refactor your objects to store a birthday instead of age. And here comes the crisis. Suddenly, every single piece of old code that was looking for user.age just breaks. It finds undefined, and your entire application starts falling apart. This is a classic refactoring nightmare. But wait, here is the ridiculously elegant solution. Instead of a massive, risky find and replace across your entire code base, you just add a getter for age. Now, when that old code asks for user.age, the getter intercepts the request, calculates the current age from the new birthday property, and just returns it. The old code never even knows anything changed. It just works. That's how you refactor like a pro without breaking a thing. So let's boil it all down. Getters are for computing data right when you need it. Setters act as your guardians, validating or transforming data before it gets saved. Together, they give you fine-grained control, they ensure compatibility during refactors, and best of all, they keep your code looking clean and normal from the outside. You know, this quote from the source material really just nails it. The true power here is flexibility. You can start with a totally normal, simple data property, and then, at any time in the future, you can seamlessly swap it out for a getter and setter to add new logic, all without breaking anything that was already using it. Look, this isn't just some niche trick. It's a fundamental tool for writing JavaScript that's more robust and way easier to maintain. So the question I'll leave you with is this. Now that you have this power, what kind of smart properties are you going to build? How are you going to use getters and setters to make your objects more intelligent? The possibilities, as they say, are endless.